Let's review the last concept before we begin the new. So when I'm looking at this problem, it seems really complicated. Lots of variables, lots of exponents. It's just a mess. However, this one right here, all of this is to the 0 exponent, so that makes it really easy because that whole thing becomes 1. So now I'm just left with 1 over x to the negative third y squared z to the negative fourth. And remember, we're looking for our negative exponents. They're unhappy. They're not liking where they're located, so they need to move. So we have to bring that up and the z up. So simplified, we have x to the third z to the fourth over 4y squared. So something that seemed really complicated, this 0 helped us out because that became 1. The x to the negative third became x to the third in the numerator. Z to the negative fourth became z to the fourth in the numerator. And both the 4 and the y terms stayed down. So our learning target today is still the same. I can simplify expressions using properties of exponents, but today we're focusing on the division ones. So let's think about what we know. To multiply powers with the same base, we add the exponents. So it makes sense that when we divide powers with the same base, we do the opposite and subtract the exponents. And that is a lot of what you're doing today. So like with multiplication, let's write it out in the long form and the short form. So the long form, we're just going to write out what it means. X to the fourth means x times x times x times x over x squared, x times x. So now we know anything over itself equals 1. So that equals 1 and that equals 1. And so I'm left with x squared. And that makes sense because of what we just talked about. X to the 4 minus 2 is x squared. So let's do the second example. We're writing it out the long way, x times x over x times x times x times x. Now this x over x cancels, this x over x cancels, and it looks like we have nothing left in the numerator, but remember there's always a 1 there, so that equals 1 over x squared. So again, knowing that the rule is that you subtract 2 minus 4 is x to the negative 2. X to the negative 2, remember, just like what we learned in the last lesson, it's unhappy, so it has to be brought down. So that makes sense, 1 over x squared. So the rule is when dividing two powers with the same base, you subtract the exponents. So that would give us x to the m over x to the n equals x to the m minus n. So some very quick examples. 8 to the 7th divided by 8 to the negative 2. We are going to subtract the exponents. So this becomes 8 to the 7 minus a negative 2. So keep, change, change. So 7 plus 2 is 8 to the 9th. And another way to think about this is it's a negative exponent, so we needed to bring it up. So 8 to the 7th times 8 squared, then we add the exponents. It works the same way. So 3 to the 7 minus 2, because we're dividing powers with the same base, we subtract the exponents. That becomes 3 to the 5th. And x to the third divided by x squared, x to the 3 minus 2, so that is just x. And again, if you get confused, you can write it out the long way, but you don't have to. The last division property is power of a quotient. It's just when you're raising a power to another exponent. This is similar to our power of a product. All this is saying is that the exponent has to go to both the numerator and the denominator, and here is why. At the long way, x over y times x over y times x over y gives you x times x times x, which is x to the third, y times y times y, it's y to the third. So it's like you are distributing out that exponent. So 1/2 to the 4th power is like the long way, 1/2 times 1/2 times 1/2 times 1/2. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. So again, it's like 1 to the 4th, and you're distributing, you're taking that 4 both to the numerator and the denominator. So when raising a quotient to a power, you just have to make sure you take the power of the numerator and the power of the denominator, both places. So let's do some examples where we're combining many of the properties. So here, you're multiplying. So we have x to the 5th over x to the 7th. You are never going to leave two variables that are the same in a solution where you are simplifying. So we could do this a couple different ways. You can think of this as division. 5 minus 7, so x to the negative 2, so the answer is 1 over x squared. I usually just think I have 5 x's up here, 7 down here, so if I cancel out 5 of these with 5 of these, I'm left with 2 in the denominator. Next one, here I have my base, which is 7, and my exponents, which are variables, so all I can do is show that I know to subtract. Alright, this next one, I'm not going to do anything with it. I could just notice that these are the same, or I could actually do the negative 4 to the 3 minus 3. Negative 4 to the 0 is 1. But again, I didn't have to do that because anything over itself is 1. Alright, and the last example on this is we have a multiplication problem. So we are going to multiply across. So 4 times 3 is 12. X times x squared, if we're multiplying powers with the same base, we add the exponents. Y to the third, y to the negative third. Here, they're opposites, which would give me y to the 0, which is just 1. So I'm just going to leave that off. And then I'm going to do 2y times x to the third. The number always comes first, and then the variables in alphabetical order. And then I can simplify. If you ignore the variables, just look at that 12 over 2. 12 over 2 is 6. Now just look at the x's. X to the third over x to the third, they're the exact same thing, so they cancel each other out. And then the y is in the denominator, so it is going to stay in the denominator. Last slide of examples. 2/3 squared. You could think of it the long way, 2/3 times 2/3, but I usually think 2 squared is 4 and 3 squared is 9. 2 to the third is 8. Y to the third is y to the third. Alright, in this last example there's a lot going on. There's power of a power, power of a quotient, power of a product, there's a lot. So I'm going to take this 2 to every single thing in here and then simplify. Although we could simplify first because I see x's, but I'll stick with doing taking this squared to everything first and then simplifying. So I have 2 squared, which is 4. X squared squared, when you're raising a power to a power, you multiply the exponents, so that'd be 4. And then y to the 6, because when you're raising a power to a power, you multiply the exponents. Over, and then this squared has to go to everything down here too. So 3 squared is 9, x squared, z to the 8th, because when you're taking a power of a power, you multiply. So now I'm going to simplify. I'm going to look at my numbers first. 4 over 9 just stays 4/9. We can't simplify that at all. Then I'm going to look at my x terms. X to the fourth over x squared. 4 minus 2 is 2. It's positive, so it's going to go in the numerator. Or I could think these two cancel out 2 of these, so I'm left with 2 in the numerator. And then the y and the z don't have the same bases, so we don't have anything to do with them, so they just stay where they are because they have positive exponents.